You are welcome back. In this video, we are going to discuss about logarithm, the subtopic of laws of logarithm. Okay, we have 5 laws of logarithm here. The first one is what we call the product rule here. After this one, also we have another one, what we call the power rule. Then we shall talk about the quotient rule. After there, we have identity rule, and lastly, we'll discuss about zero laws. Okay, let us start with the first one, which what we call the product rule. Okay, the product rule. Okay, for the product rule here, suppose you have something like this one. Let's say a exponent n times a exponent m. This one will be equals to a exponent n plus m. This is according to the rules of exponents. If you have the same base like this one, base a, and you need to multiply, actually you're supposed to sum up the exponent. That's why I'm taking the summation of n plus m. Okay, then from there, let x be equals to that one, a exponent n, and also let this one y equals to a exponent m. Okay, so now I have this one and also I have this one. Now try to convert this exponential into logarithms. This one will be like this: log x base a equals to n when you convert this one into logarithm. And also for this exponential, you can convert it into logarithm form. We'll find that log y base a equals to m. Okay, so now I have this one, and also I have this one. But also remember from the previous here, we know that when you take this a exponent n times a exponent m, the answer must be equals to a exponent n plus m. But how about this one? We know that a exponent n here is equal to x. As you see, this one, a exponent n equals to x, and this a exponent m equals to y. So instead of writing this one, you can write x times y is equal to a exponent n plus m, something like this one. Okay, but also for this one, I can convert into logarithm form because I know this is what we call the exponential form. So because this is exponential, you have to convert it into logarithm, and you will find that this log xy base a will be equals to n plus m. But also you have to know what is n and what is m. Let us refer from this one. N is equal to log x base a, and m equals to log y base a. So you have to plug it. From there, you will find that log base a x y, this one, equals to log x base a, that is the value of n, plus the value of m is log y base a. And from there, this one is what we call the product rule. For any product rule, for the any multiplication in logarithm, if you have multiplication like this one, it become addition. That is what we call the product rules in logarithm. For instance, you have a question like this one. Let us check the question. You need to find value of log base 3, then 5 times 2. Okay, suppose you have a question like this one. This question can be solved by using the product rules solution. Since I have log base 3 here, 5 times 2. This one the same as log base 3 here, I have 5. This is multiplication. According to the product rule, will be addition. Then plus log 2 under this base 3. So this one will be the solution for that question. So simply by using the product rules. Okay, let us move. The second one is what we call the power rule. Let us discuss about it. Power rule. Okay, now for the power rule, suppose you have this one. Suppose you have this one. Let's say log under base a here. Let's say you have x exponent exponent 3. We need to know this one will be equals to what? Okay, so for that question, log x exponent 3 here under base a, this one will be the same as log under base a here, but we have x exponent 3 the same as x times x times x. This is what we call the x exponent 3. But also from this one I can proceed the same as log base a. Here it is multiplication, but according to the product rule, multiplication become addition. So this one will be the same as log x base a, then plus, because multiplication here is addition according to the product rule of logarithm, then plus log x base a, then plus log x base a. This is because here we have a multiplication, and the multiplication will be the addition according to the product rules of logarithm. Okay, now we have to proceed from there. When you take this one plus this one plus this one, this is log x base a plus log x base a plus log x base a, you will find equals to 3 log x base a. So at the end of the day, if we have this one log x exponent 3 base a, we find this one equals to 3 log x base a. Simply this 3 was shifted into this side, that's why I will find equals to this one. So general, you have to note that general, if you have log under base a, let's say you have x exponent k, this exponent can be shifted into this side and it become k times log x base a. This one is what we call the power rule of logarithm. So this is what we call the power rule of logarithm. You have to understand it well. Okay, let us check the little example. Suppose you have a question like this one. You need to find value of log, let's say log 2 exponent 5 under base 3 here. Okay, solution. For that one, we have this log 2 exponent 3 under base 5 here. Okay, so for this one will be equals to what? According to the power rules, this one is a power, it can be shifted into this side. So now this one will be equals to 3 log 2 base 5. Okay, let us check the second question here. Question number 2, you need to find this one. Let's say you have log under base 5 here, we have 2 exponent 7. This one will be as 4. Solution. Okay, this log base 5 2 exponent 7 will be the same as this 7 can be shifted into this side according to the power rule, and they will find this one equals to 7 log 2 under base 5. Something like that is what we call the power rule of logarithm. Okay, so important things here is this one. Make sure you understand this one. Okay, let us shift. The next one is what we call the quotient rule. Okay, now let us discuss about the quotient rule. Quotient rule. Okay, about the quotient rule now. For this one, suppose you have something like this. Suppose you have this one, a exponent n divided by a exponent m. Actually, this one will be equals to a exponent n minus m, because we know that in division, if you have the same base like this one, then you're supposed to subtract the exponent. That's why I'm subtracting like that one. But to write this one the same as a exponent n divided by a exponent m, which is equal to a exponent n minus m, something like this one. Okay, then from there you're supposed to write, okay, let x be equals to a exponent n, and also let y be equals to a exponent m. Then from there convert this one into logarithm form, because that is exponential form. So when you convert this one into logarithm form, you will find that log x base a is equal to any, and also when you convert this one into logarithmic form, you will find that log y base a equals to m. Okay, so now refer from this one. We know that when you take this a exponent m divided by a exponent n equals to a exponent n minus m. That means when you take a exponent n divided by a exponent m, this one is the same as a exponent n minus m. We know about this one, but what is a exponent n? That a exponent n is equal to x. A exponent n equals to x. And what is a exponent m? This one equals to y. So you have to plug it. A exponent n, this one equals to x, over a exponent m, this one equals to y, which is equal to a exponent n minus m. Here, something like this. Okay, so what next from this one? Remember, also this one is what we call the exponential form. So convert this one into logarithmic form. So if you convert this one, you will find that log this one, x over y, and a certain base a will be equals to n minus m. This is when we convert this one into logarithmic form. We will find something like this one. But also you have to plug value of n and the value of m. What is value of n and the value of m? Refer from this one. Value of n here is equal to log x base a. Value of m is equal to log y base a. So now this one will be like this. Log x over y and the base a will be equals to this n, the same as log x base a, minus this m, the same as log y base a. That means general quotient rule, if you have log base a x over y, this one will be equals to log x base a minus log y base a. This is what you call the quotient rule. So you have to understand the quotient rule. It can be applicable in different quotients of logarithm. For instance, real example here. Suppose we have a question like this one. We need to find value of log base 5 2 over 3. Find this one will be equals to what? Okay, for that question will be like this. Solution. Here we need to find log base 5 here, 2 over 3, 2 over 3. This one. This will be equals to, according to the quotient rule, this one will be equals to log 2 base 5. Then it is division, becomes subtraction, minus log 3 base 5 will be like this one. It is very simple. Okay, now important things is that in logarithms, if you have division, this division become subtraction. You have to note it. That's why you have to understand the quotient rules of logarithm. Okay, let us move. After quotient rule here, we have another one, what we call the identity rule. Okay, identity rule. Okay, for the identity rule now, suppose you have a logarithm like this one. Suppose you have log a base a. This one actual is equal to 1. This is because your logarithm here is equal to your base. So in case logarithm is equal to base, then the answer must be equals to 1. So in case your logarithm is equal to your base, then the answer must be equals to 1. For instance, you have this one. Let's say you have log 2 base 2. This one actual will be equals to 1 because your logarithm is equal to base. So in case logarithm equals to base, then the answer must be equals to 1. Okay, let us check the real example here. Suppose you have log 5 base 5. This one will be equals to what? Okay, this one actually we know equals to 1, but if you want to prove it, this one will be like as follows. Okay, firstly, convert your logarithm into exponential form. When you convert this one into exponential form, we find that 5, this 5 equals to 5 exponent x. Okay, then from there, This 5 doesn't have any exponent, means its exponent equals to 1. Then 5 exponent 1 will be equals to 5 exponent x. Okay, as usual, if you have the same base, actually you must have the same exponent. So this one equals to this one. Actually, this one also equals to this one. At the end of the day, we find x will be equals to 1. Therefore, log 5 base 5 equals to 1. This means for any logarithm, in case its log equals to base, the answer must be equals to 1. That's why general, if you have log a base a, this one it's supposed to be equals to 1. Don't waste your time to solve this kind of question, because if logarithm equals to base, then the answer must be equals to 1. Okay, now let us shift to another one, what we call the zero rule. Okay, now zero rule. Okay, for this zero rule, here we are talking about logarithm of 1. So if you have logarithm of 1 and as a certain base, let's say base a, this one actual it's supposed to be equals to 0, right? So if it's from that you have logarithm of number 1 under any base, let's say under base 2, this one also equals to 0. Or logarithm of 1 under any base, let's say under base 9, this one equals to 0. So you have to note logarithm of 1 under any base, it's supposed to be equals to 0. For instance, you need to find logarithm of 1 under, let's say under base 8. This one will be equals to what? Let's say assume equals to x. I need to verify if this one will be equals to 0 or not. But on myself, I know that logarithm of number 1 always will be equals to 0. Okay, let us prove it. Firstly, you have to convert this one into exponential form, because you know that is a logarithm form. So if you try to convert that one, you will find that 1 is equal to 8 exponent x. Then from there, this is 1, but we know that any number power 0 is equal to 1. So instead of writing that 1, I can write 8 exponent 0, because I know any number power 0 will be equal to 1. So this will be equals to 8 exponent x. Instead of writing this 8 exponent 0 the same as 1, that's why I write 8 exponent 0. Then from there, I know that the same base, the same exponent. Since this one equals to this one, then actual this one also must be equal to this one. So at the end of the day, I'll find that x equals to 0. That's why log 1 and base 8, this one you will find equals to 0. So general log 1 under any base, the answer must be equals to 0. Let me write something here. Let's say log 1 and a certain base, let's say base a, actual will be equals to 0, and this one is what we call the zero rules of logarithm. Okay, always log 1 under any base, the answer must be equals to 0. Okay, here will be the end of my presentation for today, but in case you have any problem, don't worry about me. Concern with me via my WhatsApp number